Hey future doctors and engineers, I welcome you all to this new channel dedicated to the preparation of JEE and NEET. In this channel, I am going to discuss basic and advanced concepts of physics related to your preparation. The idea to create this channel is to make physics easier for aspirants without making any drama. I have more than 10 years of experience of teaching physics to JEE and NEET aspirants, and I have produced many rank holders. In today's video, we are going to discuss the free body diagram of block problems. So let's get started. So basically, the free body diagrams are the diagrams which represent the forces acting on the object or the system with their direction. Okay. If we take an example of this block which is resting on the floor or the ground, what we can represent, we can see that the forces acting on the object is the force due to gravity. The first force we can experience is due to the gravity, and the second force is the contact force between block and ground. Okay, these are the two forces which is acting on the object. Now we have to represent these forces with their direction. So what we're going to do is to draw a block, a force which is representing the downward gravitational force mg, and the second force which is the contact force, and we say it is a normal because it is normal to the ground. Okay, now there is a misconception that this normal force is basically the reaction force or mg, which is not true. Actually what happens is when you put the block on the ground exert a normal force on the block in the upward direction, but the block give a reaction on the ground in the downward direction. So this is action and reaction. This normal is not a reaction of mg. Why it is so? Because we have learned that the action and reaction pair always act on the different object, and here the normal and mg acting on the same object. So basically the normal is equal to mg, we write. That is why, because it is at rest and the forces are being balanced. But if we draw the free body diagram of the ground, the reaction of this normal to the ground is this. Okay. So if we talk about the free body diagram of this block, so we are having two forces. One due to gravity, which is acting towards the center of the earth, and we make it downwards in the diagram. And the second is the contact force. Here the contact force is represented by a normal. Okay. So this is very easy to understand. Only two forces are acting on the block. Now let's uh, talk about this second diagram. In this diagram, if we see that this mass is being acted upon a force F, but this force is in the direction which is making an angle theta with the horizontal. So what we're going to do is to firstly understand what forces are acting on the block. So for which we draw the block next to the diagram. We know this is a force which is acting on the block F. The second force is due to the gravity, which is mg. And the third force is the contact force due to the ground, which represents by n normal. Okay, so this is the free body diagram. Now we can also resolve this force to make it clear that this force is in x and y direction. What is the effect of this force? Okay, so if we represent this direction as x direction or horizontal direction, and this direction as y direction or vertical direction, so we can resolve the given force in x and y as well. So first we draw the normal, then we draw the mg. We are not going to resolve n and mg. And why it is so? Because normal and mg are in vertical direction, and we want to represent, if we want to represent the direction of the particle in y direction, these forces are going to help us. But this force F, it is neither in x and nor in y. That is why we have to resolve it. And what we're going to do is to resolve the force in x direction, which will give F cos theta as one component in horizontal direction, and f sine theta in vertical direction. Now we have completely described the various forces in x and y direction, due to which now we are going to write or able to write the equations of motion of this block in x and y direction. Okay, so this is the complete free body diagram. In the coming videos, if you comment to how to draw or how to write the equation of motion, then please let me know. I'll give you a dedicated video on that. Now, let us move to the third example. In this example, the force is not pulling the object, it is pushing the object. So, if we draw a force or free body diagram, again, we know that there is a mg which is a downward, there is a normal which is upward, and there is a force which is acting on the object in this direction. Again, this force is neither in x or nor in y direction, so we have to make the component of this force or resolve this force in x or y. So we can write mg over here, we can write normal over here, and now we have this force which we have to resolve. So if we take this direction or this angle as theta, so this is going to be theta, and this is f sine theta, and this is f cos theta. So guys, you can see that we have resolved this force. So what is the final free body diagram of this block? So final free body diagram is, there is a force which is mg plus f cos theta which is acting downwards. There is a force normal which is acting upward beta, and there is a force f sine theta. So this is complete free body diagram of this example number 3. Okay, shall we move forward? So this is the question number 4 beta. Now in this case, there are two blocks. One block is being pulled by a force F. The another is connected by a massless string. In this case, the string is massless. We are going to discuss the cases where the string will have some mass, but in this case, the string is massless. So beta, in this case, what are the forces acting on the blocks? So if we talk about the forces, there is a normal which is represented by m1. There is a gravitational force m1g. There is a force acting on this block F. There will be a tension in the string T. There will be another normal N2 on M2, and there will be again M2G. We need to understand that these two blocks are different, so these normals will have a different value. Okay, beta, you cannot write N and N on both the blocks. You have to write N1 and N2. Now, if we want to represent the free body diagram of the blocks, each block, so M2 is being pulled by the tension, and N2 and Mg. So this is the free body diagram of the M2 block. And now what is the free body diagram of M1? M1 is being pulled by the force F on the left side by tension, by normal N1 on the upper side, and the downward side M1G. So this is basically the free body diagram of this question. Okay. Now, I have to mention that there is no friction beta. You guys must be thinking, where is the friction? We are taking the examples without friction here. Okay. For friction, we will make another video. Okay. Now, if we talk about this example, example number 5, we say, again, there is a force which is acting beta in a different direction, which is not in X or not in Y. So we have to resolve this force. So this will give you F cos theta. This will give you F sin theta. There will be a normal also, and there will be an mg, There will be a tension T. There will be a N2. You can write this normal as N1 also. So we should represent it from the center of the block. So N1, and this is M2G. Now, now, if we want to make a dedicated diagram from each block, so M2, it is N2, this is M2G. M2 is being pulled by the tension of the string. If we talk about M1, so M1 will have N1 plus F sine theta in upward direction beta, F cos theta in horizontal direction, M1G in downward direction. M1G in downward direction. So these are the free body diagrams of the block problems. I hope you like the video, and if you want me to make another videos, you need to like the channel, subscribe the channel, and let's meet again in the next video, and we will discuss about the pulley free body diagrams. Okay, so that's it for today.